Okay. Okay, so let's just summarize these points then, the difference between voltage, current, and resistance. First, we'll do current first. The rate of flow of charge. So it's the amount of charge passing by a point per second. Okay. The symbol for charge is Q. The symbol for time is T, little t, capital Q, little t, and capital I for current, strangely enough. So it's you can calculate it by the change in charge over the change in time. The electrons don't necessarily need to be moving more quickly. There could just be more of them moving by per second. So if you had a lot of electrons able to move because maybe the wire is thicker or perhaps the metal has a lot more free electrons, then then you're going to have more charge, or perhaps maybe the thing that is flowing has more charge on them. So, for example, we know electrons have a certain size charge, but if we could have another particle that might have a larger charge, and they might not necessarily be moving any faster, but because they're carrying more charge, then when they're flying by at the same speed, they are actually the current. There's more current per second, so it's the rate of flow of charge. So be careful of the word speed. Voltage is so the word the equation is the energy per charge. Okay, energy per charge. So but really you're looking at the difference between 2 points of the energy per charge. So how much energy has a bunch of charge lost or gained between 2 points? Now, it's true that a battery has a voltage, and it's true that the higher the voltage, the more powerful the battery. But you can also have a light bulb will have a voltage too. That doesn't mean the light bulb is giving the electrons energy. The light bulb has a voltage because the voltage is the difference in energy per charge between 2 points. So in the case of the light bulb, the electrons are of course losing energy. As you measure the voltage, you're measuring it between 2 points, between point A and point B. How has the energy per charge changed? Maybe it's gone up, maybe it's gone down, maybe it hasn't changed. If it hasn't changed, the voltage is zero. Otherwise, it's not zero, and it's either positive or negative depending on how you wire up the voltmeter. And this is why voltmeters are in parallel and why ammeters are in series. Well, the voltmeter you're measuring between 2 points. Well, an ammeter you're just measuring at 1 point. The current is going to, and because also current's the same in series, I can put the ammeter before or after it. I can't, and there's obviously no way of putting the ammeter inside the light bulb itself, but because the current's the same before and after the light bulb and in the light bulb, then I can, by putting the ammeter there or there, I'm measuring the current in the light bulb, which is the same as after the light bulb or before. Now, resistance is how difficult it is for the current to flow. It's the amount of necessary voltage to get a certain current. So let's say I wanted to, so 1 ohm, which is the unit for resistance, is how many volts, the resistance in ohms is the amount of volts needed to get a current of 1 amp. It's the volts per amp. Okay, so an ohm is 1 volt per amp, an amp is 1 coulomb per second, and a volt is 1 joule per coulomb. Okay. All right. Oh, I did make a video. I just realised. Okay. Anyway, there's a second video. I'll stop that there.